Anyway, thanks for coming back. Let's continue. So we're still in this spaghetti here. We talked about the front door, the offline part, and now what I'd like to do next is talk about online and then about evaluation, and then leave some time to address, to certainly address one of the questions that came just before the break. So, what should you be working on? So, online. So remember, we have our indexes. We get a query. When we go down and right to the left, we try to understand the query, see what verticals it may need, produce the rankings for those verticals, get the top tier results, and then percolate up everything to produce the result page. Right, so I'll skip over the top K retrieval in the interest of time, and I want to spend a bit of time on each of those three steps: query understanding, blending, and vertical rankers. Right. So query understanding. So quite a few things may happen concerning query understanding. So the things you might do is suggest alternatives that you're confident about, maybe generate a structured query that from the incoming user string to send that to a structured database. You could apply hotfixes to overcome a problem. If you think it's a question, a direct question that you could respond to with a direct answer, you'd like to do that as well. So those might be some changes to the query as it comes in. Some of this is maybe bounced back to the user immediately. Other things won't show up until a bit later. Classification goes on, quite a bit of it. The intent, the topic, how well will this query do, what is the language of the query, what is the task that the user is engaged in, what is the device that the user is working on. And then there may be various types of labeling or annotation going on, either for localization or the session, or whether it's or there are entities in the query. And you might also, at that stage already, want to get an understanding of what type of query it is in terms of head or tail or torso. That's going down from right to left in this in our picture. Going up, first, we're almost ready to return the SERP, so we need to generate the SERP, adapt it to the device that we think we've detected. We might want to do some translation, and if we have direct answers, we might want to inject those. Again, the direct answer could be, if the query is 12 euros in dollars, then the direct answer is the conversion rate, right? Or the temperature in Thessaloniki, and the direct answer is, something like what you showed earlier this morning. What I'd like to do is talk to you about intent for a while. So, by trying to identify intent, what the system will try to do is, enable itself to produce rankings or produce SERPs that take the intent into account. For instance, if it detects that a query might have an image intent, it will also return, will activate the image vertical and might return image results along with web results. Now, in the literature on intent, you can see roughly there's a lot of attention for this over the past decade. You can roughly see two lines of work. One is intent classification. So there is a fixed set of intents that you're interested in, and the incoming query, you try to associate it with one of these intents, or perhaps a distribution over these intents. That's one line. The other line is it's not as supervised. You try to discover the intent. So let me talk about those for a while. Now, so first about the intent classification. A very influential one, which was described by a paper by Andre Broder in the ZDR Forum 10, 15 years ago, classifies queries by their search goal. Is it a navigational query? Is it an informational query? Is it a transactional query? Other intent classification papers have looked at trying to classify the task, so purchase, a computer, a job finding query, book a ticket query. Other intent classification work looks at more semantic topics based on a hierarchy that the engine might have, for instance, Wikipedia or Demos, the Open Directory project, and then try to assign categories, topics from these hierarchies to the query. Those could be all over the place. They're from very fine-grained to very high level. So cars could be very high level semantic intent descriptor assigned to a query, but you could also have Mercedes 600 SL something assigned to a query as a label. Right? It could be specific, general. Other intent has to do with those verticals that I mentioned before. So this query, what is it looking for? For images, for video, for apps, for direct answers, for generic web, for maps, for yet another very important type of intent classification has to do with freshness and time sensitivity. So does this query that is now coming in, does this query require very fresh results? Because what would you use to try and detect that? Could this query possibly desire very fresh results? How would you address this? I'm not going to ask live.
Compared to previous queries?
I'm sorry?
Compared to previous queries?
Compared to, what would you compare?
If you have a saving of all stuff, these are stuff.
I'm sorry?
If you have a guidance of all stuff, you have to compare how similar they are.
Compare the similarity between the current query and previous queries.
Okay. How would that inform us about the fresh intent of that query that we're now looking at? New content in the query. Okay, so this query hasn't been submitted before. Okay, but it could also be some free query, right? Or a typo. But there is, I think, if you change your idea a tiny bit, then if other people have been asking for this too, surprisingly more often now than in the past, something might be happening. So you look at the query volume and change in the query volume.
Maybe also that if the query contains terms that are related, to timeliness. So if I look for, say, train schedules to Athens, okay, I want fresh results. Okay, so I want fresh schedules for today,
Okay.
not the ones that.
Yeah, so then you probably want to so the idea is look at, if I can paraphrase your suggestion, look at activities that might be related, or tasks that might be related to this query, and whether they have something that asks for
That
freshness.
has a temporal dimension.
Yeah, so you could do some sort of temporal information extraction on the query, either implicit or explicit. What else could you do?
So the related documents, we look at the recrawl rate.
Okay? Yeah, indeed. I would also look at the production. Do we all of a sudden see lots more documents on this topic coming in? So that might be of a slightly different nature than what you're suggesting. But it could be, so if something happens in the world, and it's a newsworthy event, lots of people will talk about it on social media, on news sites. You'll see a change in production volume. Yeah, so those would be for news-ish queries, the strategies. Your idea with the looking at big changes in query volume, your idea with big changes in content production. And yours is different in nature. Somehow these actions that I'm creating, that my queries have to do with, require up-to-date information. So it could be purchases, bookings, travel,
Also clicks, probably. So if similar queries, if previous users, have issued similar queries and have clicked on links that are about recent information, fresh information.
Exactly. So now we have the third signal, right? There was a query production, a query volume, content production, and also what do users do? Do they start clicking for much more fresh results? More now than maybe in the past. And then maybe something has changed. There's a news need, perhaps, or a freshness need. Yep, thanks. Okay, so this is hardly readable. I'm sorry about that. So classifying these queries in categories is often challenging because there are just a few words that you get, but there may be a lot of context that you could use. So, and we saw 3 types of context already: query volume, production volume, and click behavior. Those are, and we could also look, for instance, at earlier in the session or earlier in sessions by the same user. These contexts could all help us identify the intent, could all help us improve the quality of our classifier. Now, typically what you see in this setting with the intent classification is handcrafted training data and handcrafted inventory of intents. Now, here is one of those inventories of intents. Let me see if I can read it. Oh, wait. A bit better. So, this is from a paper by Rose and Levinson, 2004. It's a follow-up of that Andre Broder paper that I mentioned before. So that Andre Broder paper classified queries by search goal, navigational, transactional, informational. This refines that hierarchy. So navigational, informational, and then instead of transactional, they have resource. So, for instance, what you see here is they've refined the informational class in directed, undirected, advice queries, locate queries, and list queries. If you can't read it, I'll read some of the descriptors here. So the advice query is, I want to get advice, ideas, suggestions, or instruction. And the example query here is help quitting smoking or walking with weights. List. My goal is to get a list of plausible suggested websites, i.e. the search result list itself, each of which might be candidates for helping me achieve some underlying unspecified goal. The description, specific examples, Florida newspaper, purse, Amsterdam universities, and travel. Resource, so download. My goal is to download a resource that must be on my computer or other device to be useful. And then example queries, Kazaa Lite. I hope you get the idea. The way that they came up with this is by sitting down, looking at queries, looking at where they failed, trying to understand the specific types of queries where they failed, and then trying to identify those as they come in. And you can get some intuition of the different strategies that our search engine might want to apply and put to work in order to respond to these different types of queries, right? So this query is quite different from, let's say, what they have here is a closed directed query. A closed directed query is, I want to get an answer to a question that has a single unambiguous answer. For instance, example, 2004 election dates. That's quite different from Amsterdam universities. Okay. The Rose and Levinson, from whose paper this table comes, did both manual. They hired some human annotators to do labeling. They trained, I think it was an SVM classifier, to classify queries automatically, and the scores were sort of okay-ish, depending a bit on the classes, but 60–70% accuracy. Intent discovery. So that was classification. You have a fixed inventory of intents, you have manually labeled data, and you just classify. Now, intent discovery. So you don't have a predefined set of categories, but you just group together users with similar information needs. Because, for instance, they click the same group of URLs, even if they have different queries. And so again, here you could use more graph-based intuitions, like we saw before the break. Click graphs have been used to do query clustering, and then try to find out what the intent might be. So when you've clustered a number of queries, what is the right label? What category would you assign to this? Now, what you see in many of these studies is that the intent is assumed to be static, and it's often assumed to be binary. So it's either this intent or another intent, but not both, or not a bit of both. So here's...
sorry. Thinking about the Rose and Levinson paper.
Yeah.
Have there been any follow-up attempts, like for maybe like crowdsourcing labels?
I think so, in more domain-specific settings.
I see.
This was in a generic web setting,
Okay.
and I'm sure they do quite a bit of crowdsourcing themselves, but don't publish about it.
Okay.
Yeah, so so for instance, in the cultural heritage domain, there are a couple of studies. So search in cultural heritage domain with fairly fine-grained intents, like well, not the same, but somewhat comparable to what we saw here with crowdsourcing, and also interesting differences between expert annotators who think they know and who may actually know users and searchers, and you know, the real in quotes, crowd. Yeah, I don't have a pointer at the top of my head, but I can look it up.
Okay.
Thanks.
Yeah, thank you.
What is this? Shifting intents. This is goes back to a paper by Kira Radinsky. That's the work that she did with a bunch of people at Microsoft Research. And looking at changing intents over time. Here's an example from one of their papers, the query Easter. So the same query, but looking at this query at different moments in time as you get closer and closer to Easter itself. Same query, but different intents, depending on the temporal distance to the actual Easter event. So a few weeks, how do you know this? Well, you look at the documents clicked and you group these together and then you try to understand the dominant clusters there. That's what Kira and her colleagues did. And so what they saw is that a few weeks prior to Easter, many of the queries landed on pages. So a SERP was produced, people clicked on the SERP, many of those clicks landed on pages that gave an answer to the question when Easter is. A few days prior, just a few days prior to Easter, many of the queries landed on pages that explain what you could do over Easter, which movies were showing, what festivities were, what concerts, etc. And only during Easter itself, there were quite a few clicks, significantly many clicks that landed on pages that explain the meaning of Easter. So again, the phenomenon here, it's not about Easter, it's about the same query, but at different moments in time, has a different intent. We've seen similar things in log studies that we did with search engines of the Dutch municipalities in the run-up to elections. So the way that elections work in the Netherlands is everyone who is allowed to vote gets a voting card. And that voting card has an address of a voting station that you need to go to. And then you submit your vote there. So what we saw, for instance, that a couple of weeks before the elections, people would ask about the voting cards. They hadn't received them, or there was a mistake on them. A couple of days before the elections, missing. Or I can't vote in this station because I'm going to be at the other end of the country during the election day. How can I transfer my voting card to that other polling station? And on the day itself, and the queries were always the same, it's just the intent were different. On the day itself, opening hours, exact address, telephone numbers, etc. of those voting stations. So same phenomenon. Richard?
Yeah, the question is, you mentioned that the data that you leverage on here are clicks, but I guess you can also leverage the different temporal distribution of the auto-completions that get chosen.
Yes. Yeah, so great suggestion. How people respond to auto-completions and what completion they actually end up selecting is also a good reflection of their intent and of their changing intent, if indeed you're dealing with queries that have a changing intent. Yeah, thanks. Right, this is another one. This has to do with shifts in freshness intent. So you have a query that doesn't have according to your classifier, a high-performing classifier, doesn't have a freshness intent. Now, queries change and intents change, as we've just seen. And these are actually, and there may be events in the world that trigger a change freshness intent. And you want to detect those shifts as quickly as possible, because if you don't detect it, they will leave your site and they will go somewhere else to the users to satisfy their need for fresh results. And so here's an interesting experiment. So your freshness detector for this query begins to become a bit unsure. This query may be shifting from non-fresh to fresh, but we don't know yet. And it may take a few hours before we're really sure that it is now a query with a fresh intent. We don't know yet. The problem that was tackled in this paper was, can we speed this up? And we speed this up by a lot. There are online learning to rank methods that you'll hear about a lot more on Thursday morning. Those you could use, and those give some improvement. But the idea that was put forward in this paper was just start exposing a fresh result for this query that you think might now need fresh results, whereas first it didn't do. Show one fresh result at the top of the rank list. So you're taking a risk, you're gambling, because you might be wrong. So you want to, if you run this experiment on your live users, or your live search engine, you want to restrict that and run it for as short as possible, because you might be annoying your users. So in this paper, they managed to do this and reach a high level of certainty whether or not the non-fresh query has shifted to a fresh query with just 11 or 12 impressions. Okay, that's not a lot. And that seemed like a very cheap experiment, right? To run with your users. I was asked not to keep my phone close to me because it interferes with the mic. How are we doing time-wise?
We still have about 40 minutes. So
40 or 14?
40.
Okay.
Because we started late.
Okay.
Let's say 35 to be more
Okay. I'll stop asking now because you're reducing it as we go. Now remember, so far we're still in this talking about the online block. We started up there, query understanding, looked at intent in a bit of detail. Now the next step is down is the blender. What does the blender do? Well, as its name suggests, it blends results. That's when it gets the result. So going up, it will blend results, but going down, it will, in a sense, activate rankers in the pipeline. I need results images. I need results from news. I need results from social. I need direct results. Direct answers. So that's what it will do going down. Select rankers, set parameters, and if appropriate, call for direct answers. Going up, it will try to merge those results. And we're going up, we're about ready to hand over a cert to the front door. Merge results, where it may bring in additional constraints such as diversity, and it may do quite a few things in terms of selecting specific aspects of the interface. For instance, if it's a heavily entity-oriented query, it may decide that it should show an entity pane, right? So this small knowledge card on the right-hand side that you see with many search engines nowadays. You must have seen this. Anyone has not seen this? Okay. And it will do device tailoring. So I want to spend a few minutes talking about diversity here. Philip Rudlinski, in one of his papers a few years back, makes this distinction between extrinsic diversity and intrinsic diversity. So, extrinsic diversity is actually not all that interesting. It's something you need to deal with, but it's not all that interesting. So that's things like different possible readings of a query like Jaguar or Apple or Ajax. Right, if that's all you have and you have no further information, you're not quite sure what you should return, and you should probably try to return results from many of these possible readings. And simply with a query like Ebola, as it has many aspects: health, economy, travel, many aspects, and you should probably try to return, if you have no further information about what the user wants, you should probably try to return many of these aspects on the SERP. That's extrinsic. Now intrinsic, which may be a bit more interesting. So diversity as a part of the information need. So here you have a scenario where no single result will fully answer the information need. The user might want different views, might want different options, and may actually be out there to get an overview. So maybe this is one of those, if we go back to the Rose and Levinson queries, or typology, an informational query that asks for a list of things. Okay, I'll have to do my trick again here. I want to okay, so this is one or two slides from a study that a former PhD student of mine, Mark Bron, did working with media studies researchers. So what do media studies researchers do? Well, they study the media. And they're often interested in finding out what the different perspectives are on a topic in the media. And of course there are different media, so maybe they want to do a study that cuts across different media types, or they might do it in sort of traditional print media, and then in that case they want to cut across different newspapers, or they might do it across a period, and then they might select publications from this decade, the previous decade, 2 decades ago, etc. This study is about the first stage of their research process and of their search process. They often start with a very generic description, so it could be the perception of Greece in the Dutch media. Okay, so you go to you're the media studies researcher, you go to your archive, you type in the query that captures this, and you get back thousands and thousands of hits, because Greece has been in the media a lot. Radio, TV, newspapers, social, way too much, way too many.
We're doing our best.
Yeah, it's a collaborative project. So they need to. What would happen next for these researchers? Well, the next stage is they select material and go read it in detail, or go watch it if it's TV, or go listen to it if it's radio. Consume it in detail and then write an essay about this perception question. You know, even if we limit their search to, say, a video archive, then they can at most deal with between 150 and 300 video items and watch all of those in detail and then write their paper. Otherwise it's simply too costly. So what they need to do is start with a general information need, reformulate and reformulate until they get a query that identifies a subset in the archive that is still within that general topic, but also produces a result set that is manageable. So they go through an extensive process of query reformulation, which is what we've tried to describe here. This hopefully is finally a readable plot. It took a while, but finally we have one. So they start with an initial idea, try to formulate an initial research question. So they have the big question, but need to sharpen it to something that produces a manageable result set. That often involves background study, so reading up, consulting Wikipedia, or so you see a lot of going back and forth here. Revising the research question. Okay, so what was important for them is to not be caught by some sort of tunnel vision when they go from their big query to something specific. That's their whole point, to give a broad view on an issue, not a narrow single view. So, rather than us trying to solve this algorithmically for them, we thought we would solve it for them by changing the user experience. So here what you have is a double interface, so you can submit two queries, and you get two result lists down here, and you see the query volume for the two queries, the result volume for the two queries over time, and you see similar panes, for instance, a genre, you can zoom in on entities, what have you, left and right. Right, so rather than us trying to solve the diversity problem algorithmically, we solved it, or helped them solve it themselves. That was not actually how we originally set out to study. We actually had planned to do more algorithmic work, but that proved to be challenging, A, and B, they wanted to be in control all of the time. Not just at the beginning and at the end, all of the time. And so this is a nice example of this intrinsic diversity, where there is an initial initiator query, as we had it on the previous slide, and then lots and lots of different successor queries. Now, how does this process evolve? We did extensive interviewing with those researchers. So here are three take-home points. As they go along their reformulation process, their questions, their queries become more specific. So we saw an example earlier today with the taken from the query flow graph paper, where we saw specialization and generalization and parallel moves. This was mostly specialization. Okay. Okay, next phase in the online block. Re-understanding gender and vertical ranker. Yeah.
So one question on the diversity problem. Is it necessarily part of online search and retrieval, or could it also be tackled to some extent in the offline analysis?
You could do some work in the offline analysis, for instance, by enriching documents with different topics or different. For instance, one example we saw was the demos or ODP categories. At the document level, you could do that you would typically do that offline, but understanding whether an incoming query is looking for diverse results, that's something you would have to do online. Yeah. But you're right, a lot of pre-processing at the document end, you would probably do offline.
Just another question regarding that again.
Yeah.
You spoke about taking some sort of algorithmic approach, at least trying to take some. What were some of the ideas out of that? What was some of the intuition behind that? And why didn't you take the more? I mean, I understand that they needed control, but what was the initial idea for the algorithmic approach?
Okay, thanks. So is the question clear? What did we have in mind when we wanted to compute these diverse results rather than let them go there? Well, there's an old method that actually goes back to a two-page ZGR 1998 paper that does the following simple thing. So you do a normal retrieval run, so you have your ranked list, you pick the first one, and then you go down the ranked list. So you pick the first one, let's put it here. We go down the ranked list until we find one that is sufficiently relevant still, but also sufficiently different from the one that we selected. Okay, so you take that, put it there, and we continue.
This is the MMR paper.
The MMR paper, right. So we tried that. They didn't like that because they again it was an issue of control. How did we set the parameters? And the different people thought that different of these researchers thought that different parameters were needed. We also played with another method. We get the ranked list. We cluster the top couple of hundred, I think 300 or 400, and we return a good what's the word, sample or representative of every cluster, and then iteratively if they select a cluster, we could then do further clustering. They didn't like that because they felt that there was not enough of a tight connection between the description that we generated for the cluster and the cluster itself. So again, there were control issues there in a sense. What is the cluster about? Thanks, by the way, for both of these questions. Free understanding, blending, ranking. Now, Arjen de Vries will tell you all about ranking models on Friday morning. What I'd like to do is spend some time talking about those. So there could be many criteria for ranking. Relevance. So is this document about the same topic or topics as the query? In a setting where you're say doing media monitoring, This impact on reputation might be a criterion. If you're doing a literature survey, importance of a publication it could be a criterion. So how much influence has it had over time? Timeliness, if you're looking at more temporally oriented queries. Quality, is this properly laid out and written, this document, to which degree? Bias, or lack of bias. Does it fit with what I'm trying to achieve, or does it fit with what I know about the topic? How interesting is it, etc. Now, the traditional way of developing these rankers was you develop some intuitions and you think about what it means for a document to score according to these definitions. For instance, in the case of relevance or aboutness, what does it mean for a document to match a query? And then many ideas then boil down to combinations of term frequency, so how often do the query terms occur in a document, document frequency, document length. And here, for instance, is a formula that many of you will know, the PM25 model, which combines each of these. And over the years, we've seen many ranking functions being proposed in the literature. If you want to group them together, you could do one way of doing that would be like this: rankers that look at the content, rankers that look at structure of documents or structural aspects somehow, and rankers that are mostly based on interaction behavior, interaction signals. And we've talked about some of those earlier today. The structure-based, for instance, PageRank is one that you could call structure-based ranker. That looks at how important a document is according to the links that it receives and the importance of the sources of these links. Of course, there are also, this is not a strict classification, there are also mixtures. So if a certain type of content occurs in certain elements of a document, then it's much more likely to be a good descriptor of the document than if it occurs somewhere else in the document. This sounds vague. What do I mean? For instance, the way that journalists typically are taught to write newspaper articles is the key points should be in the lead. You know, that those first few sentences often set in boldface. And so if you have a content match on the lead, great. If you're doing literature search and you find a content match in the conclusion, and then especially in the part of the conclusion where the results are being reported, not so much the future work, but the reporting of the results, great. If you find a content match in the related work, that's not necessarily a good indicator. So when you have this many rankers, dozens and dozens or rather hundreds, it's quite natural to think of documents and ranking documents as you represent them as features according to those scores. And when you get yet another ranker, you add this other ranker, the scores of this other ranker, to this feature vector, and you somehow learn to combine all of these feature vectors. And over the years, since the late 1980s and well into this century and ongoing, there have been many ways to to learn many proposals for learning to combine many rankers. And here are a few of them. If you want to make a bit more sense of them, it helps to group them. One grouping that you often find in the literature is pointwise, pairwise, and listwise. So pointwise learning to rank, pairwise learning to rank, and listwise learning to rank. Any idea what these mean?
So pointwise approach is that where you score based, where you try to predict the score of a document, and the pairwise the relative score of two documents, and the listwise approach would be where you just try to evaluate the overall rank list.
Yep. So in pointwise, you try to learn the score. In listwise, in pairwise, you try to learn the relative order. These two documents for a given query, should they be like this or like that? And in listwise, as you said, you try to learn the best ranked list for this query given your collection. Now, the development of these rankers and the development of these learn to rank methods was traditionally done offline. So you train your ranking model offline, and then once the performance is where you want it to be, then you take it online and you run it. And then after a while you might want to retrain it. So you get more label data, you retrain it, and you bring it online again, the improved version. Now what we've seen over the last couple of years is a slow move away from this paradigm to more weakly supervised rankers. So those are rankers that, or rather combinations of rankers that improve by being used. How is that possible? Well, intuitively, the overall ranking function is some sort of combination of dozens or even hundreds of ranking functions, and you improve by changing their relative importance. And maybe this one should be a bit more important and that one less. Of course, those weights could be the function controlling those weights could be highly nonlinear, and the space with hundreds of features is extremely complex. But that's the idea. Rather than training it offline, well, first train it offline, then once you're satisfied that it's good enough, you run it online, and then you adapt it while it's being used. How would we do that? What is the one thing that we get? Clicks. Right, think of that big picture from the start again. We have the retrieval system and we have a user. You get queries going from here to there, clicks going from here to there, or not. So a simplified picture here. The index, top k retrieval, this complex combination of many ranking functions. We produce a SERP and we get some clicks back. The traditional way, you train with queries, with labels, you evaluate offline according to some metric, using a test set, a held-out test set. And then once you're satisfied that this is this combination of all these scoring functions is now performing sufficiently well, you take it online and you expose it to users. This is the other world. As you said, we get clicks, we use the clicks for online evaluation. We choose a metric that suits us, that expresses what we wanted to express. We learn, and we change the ranker as we go along. We already saw one example of this, right? Earlier with the freshness detector. We detected from the clicks that this query now needs fresh results. We changed the freshness detector and we changed the ranking. You could say, well, that was a bit ad hoc. Maybe it is, but it almost feels like a hot fix. This needs a change, well, change. Rank it at the top.
Maarten, 5 more minutes.
Sorry?
5 more minutes.
Okay, then I'll leave it with this. Okay, so finally then about evaluation in 5 minutes. Oh, that went fast, from 40 to 5.
Yeah, it's 35 minutes.
Okay. From 40 to 5 in 10 minutes. Okay. Subjectively, of course. Right, so what I'd like to say a bit about here is A/B testing and interleaving. And following up on your idea of using clicks for learning. So throughout this school, you'll see 3 families of evaluation methods. I guess later today we'll have 4 lecturers talking about offline evaluation mostly. We'll see quite a bit of user study type of evaluation in Diane's presentation, I'm sure. And then Katja will talk again about online evaluation. I'm going to give you 1 or 2 slide summaries for each. Of course, I don't do justice to these approaches at all, but that's why we have hours of lectures still ahead of us. So in the offline evaluation, what do? We collect a set of queries that we think is somehow representative of what our users typically need. We describe the information needs. We have assessors that determine which documents are relevant. And we somehow evaluate systems based on the quality of their rankings. So we look at the ranked list, and we did, for each item returned in the ranked list, we determine whether it's relevant or not. And so there are some great aspects to this. A is you can run these experiments without needing a live system, without bothering live users. You can run them again and again and again. It's highly reproducible. There are also some disadvantages. The assessors that judge the documents may actually not be a good representation of the population that you're targeting. And also assume that relevance is the same for every user. User studies in 3 words. So we here, that's for instance what we use in that study for diversity that I mentioned before. So you take this relatively small set of users with multiple retrieval systems, and you ask them to complete some tasks, and you learn about your system by observing what they do and asking them if you see differences, how those came about, why were they doing what they were doing. It's great because you get great insight into what drives them, what makes them succeed, what makes them frustrated. It's also hard to set up, hard to do well in one go. It's expensive both for the people that you need and for the experimenters. And it's hard to rerun. Online, we observe implicit behavior, could be clicks or skips or saves or forwards or likes. And there are two main methods that one uses to infer conclusions from observed differences. One is A/B testing, the other is interleaving. So in A/B testing we have two systems, A and B. We bucket the population, meaning that some of the users only get results from system A, the other users only get results from system B. And then we observe whether they behave differently. Do users from system A spend more time? Do they generate more clicks? Or do they abandon the result pages faster? And if we observe a difference, we conclude that, well, A beats B or B beats A, depending on how the difference is.
But doesn't that depend on the user groups? I mean, shouldn't both the user groups be relatively consistent then? So if you have group A, which is click-friendly, and group B, which is not click-friendly.
Large groups, think very large groups, thousands or tens of thousands or hundreds of thousands of users. And not just a small segment of your population, but a large segment of your population. So hopefully these are roughly the same populations. But yeah, good question. Interleaving, so so different users may get a different experience, right? In interleaving, all users get the same experience, but you still try to understand whether two systems, A and B, are different. How do we do that? Well, in comes a query. We have system A and system B. System A produces a ranked list. System B produces a ranked list. We take those, we interleave them, we put them together somehow, and this combined ranked list is then shown to everyone. And then we observe the clicks. Suppose we get a click. Who contributed the document that got the click? Was it A or was it B? Right? And then if A contributed more documents that generated positive implicit feedback than B, then great, A wins. If B, then great, B wins. Or maybe there's no difference between the two, or no significant difference between the two. So the choices that you have to make here are, how do I put the ranked list together? And how do I give credit? And when I observe something, how do we give credit to this guy or that guy? What if they both contributed it, but at different ranks? What do you do in those cases? The advantage of this second approach, interleaving, is that you need far, far fewer impressions by 2 or even 3 orders of magnitude than with A/B testing to arrive at the same conclusion. Okay, that's all on the slides. I now have 1 minute left.
Yeah.
Okay, so let's wrap up. So this was the bigger picture. Sorry, I rushed through the online evaluation, but you'll see more of it in Katja's presentation on Thursday morning. Julio, are you guys doing anything with online evaluation? No. Okay. So now you have every reason to stay here at least until Thursday morning. So this was the bigger picture I tried to get across. We have 2 agents, users and systems. They perform actions in response to the other's input and actions of the system, and we looked at front door, offline, online, and evaluation components. Now, two things in conclusion. One is, if you look at the standard literature, standard textbooks on IR, this is mostly absent. Much of that is absent, and there's a lot of emphasis on offline and on offline evaluation. The point today here has been to try and rebalance that a bit, take this seriously, take online seriously, both algorithmically and in terms of experimentation. That does require user data in many cases, or at least simulations of user data. Now, working with user data comes with issues. Getting it is not always easy. Then sharing it is usually out of the question. But there's also a bit, so privacy is a big thing you need to take into account. If you do get logs or get a chance to work with logs, make sure your institute approves of this. But there are also other things beyond privacy. Here's a screen dump from a query auto-completion facility taken this morning, well, actually during the break. This is a query auto-completion. This was my query, and these are the completions. What should you do about this? This is clearly, but this is probably the most popular completion at work. If it is, then I would suggest the first thing we need to do is come up with better prediction and ranking methods here, to be fairer, at least. Similarly, when you base many of these online decisions on online data, there are always bigger groups and smaller groups. The bigger groups usually have better statistics. You can do more accurate estimations, you can do more accurate predictions. The smaller groups and the smaller types of user groups, less accurate, you make more mistakes. How do you correct for this? How do you make sure that you don't disadvantage one group of users because they're smaller, and moreover, if you average across all users, they're 12%, the other 88 are perfectly happy. And as we begin to move away from offline learning and offline learning from hand-labeled data to more self-learning devices that explore and discover and come up with new rankings, come up with new classifications, we need to begin to worry about, or at least think about, how we can explain what's going on. Why did this ranking end up this way? Why was this document classified that way? So there was a question earlier this morning about what should we work on. This is something you should work on. And here's more stuff that you should work on. Anything online. I mean, seriously, where you don't assume that you have full and complete knowledge of the phenomenon that you're studying. You have to adapt as interaction takes place. Many of the methods that people like me grew up with, or previous generations, assume complete knowledge, assume that you have training data that covers all the phenomena that you might be interested in. And this, I think, is also really important. So I talked for a bit about click models. as a way of capturing one tiny aspect of interaction behavior of online users. There are so many more aspects of user behavior that you could model, that you should model, both to understand what's going on and to help your algorithms either to perform online or to be able to run offline experiments based on your models. So I'd like to conclude by thanking everyone who made the research possible that I talked about today. And I'll leave you with those resources. So those are textbooks and some offline evaluation campaigns that should provide you with lots of inspiration. But don't forget, they actually only cover 2 of the 4 blocks that we've been talking about. So someone joked the other day that this book, Modern Information Retrieval, which is at the top there, which is a great book, which is an insane number of citations. It's called Modern Information Retrieval, that it's time for a postmodern information retrieval book that actually covers many of the things that we've talked about that are not in textbooks yet. Thanks. Do we have time for questions?
Yeah, for a couple of questions.
Okay, a couple.
What do you consider the toughest type of question to answer? From a system point of view.
Questions from students. This one.
Well, the toughest type of algorithmic questions are the ones where you have to explore to be able to find better solutions, but as you explore, you take risks. And so the toughest ones are, and you know you cannot correct for mistakes. Once you've screwed up, you've screwed up. You've given someone a bad experience. So these are tough algorithmic questions. There's also a positive side to this, and that is, as you know, with these online systems, they log everything. How much can we learn from the logs offline? So suppose we have system A, and system A runs, it's the production system, we log whatever we can, and now you come and visit my lab, and together we come up with a fantastic new system B. We think it's super. It will change the world. We need to test it. All we have is the logs from system A. Can we somehow use all this historical information to learn something about new systems? It turns out that it's doable as long as the new system is not too different from the old system. You can sample from the data in such a way that any ranked list that you might produce with this new system is sufficiently similar to something you've seen in the past. But in a sense, that is a recipe for conservatism. It's a recipe against jumps ahead. So how can we learn from historical material? And of course, nothing comes for free. If our joint new ranker is really revolutionary, then we will be taking a risk by assessing it on historical material, but then at least we'd like to estimate the size of the risk. So I think that's an important area. Learning from historical data, it's a difficult area, but it's an area where if you're into difficult models, and there's lots of entertainment.
Is there a moral responsibility for practitioners of search to show information that is fair? Is there a moral responsibility for practitioners of search to show information that is fair for the student?
Is responsibility for a search engine to show fair results.
Yes, all results, as in your example, is that the responsibility of the search engine? The practitioner.
Is fairness a responsibility of search engines or search engine engineers?
Good question.
Big question.
And your alternative question is, should a search engine censor what people think? Because what you showed there was just a reflection of how of society, right? And so should you censor that? Because that's a lot of people.
It's not of society though, it's of the people that use that system.
Sure, of the society you
So
use.
that's of that use that system.
There is certainly a few. It's not good enough to say, well, this is what my algorithm says, and my algorithm is neutral because it's just a bunch of equations. I don't think that's an acceptable answer. The next step is you get into this discussion that Life immediately brought up. I think there is a responsibility. I don't know quite what to do.
And then a third point of view is, as a company, what is going to make me more money? Because they have a responsibility to their shareholders and no one else.
Thanks for the question. Anyone else? But I do think, of course this is a one-sided answer, but I do think there are great algorithmic challenges to this. Of course there are societal challenges to this question, but also great algorithmic challenges. Privacy-aware data mining has slowly come up over the past decade or so. These issues like fairness and accuracy and transparency are only now emerging. So most of if there are any technological solutions, then they're probably easy to beat. So if there are no further questions, let's leave it at this. I'll be here all day. So please, if you have any further questions, do come and talk to me. I'll give the slides to Theodora, and they should be online soon. Thanks.
Thank you.